Are swallowtails beneficial for flight? The long outermost tail feathers of barn swallows are well known as a classic example of an intersexually selected trait. Under this sexual selection hypothesis, long tails are thought to have evolved mainly to attract potential mates, thus providing a reproductive advantage, which may offset the foraging costs of long, obstructive tails. Later, however, an alternative explanation of the function of long tails, the aerodynamic hypothesis, was introduced. They proposed that the long swallowtail evolved because it was useful for flight. By experimentally cutting birds' tail feathers to various lengths and measuring its effect on flight performance, they suggested that only 10% of the length is costly to the bird's flight, whereas the remaining 90% is thought to be beneficial. The aerodynamic hypothesis was a novel explanation for the evolution of long swallowtails, but the experiments had limited validity due to methodological flaws, and it was unclear whether their measures truly captured the actual costs of long tails in the bird's ecological context. To determine whether long tails are costly or beneficial to swallows, this study shortened the tail length of females and then recorded the observed feeding rate to their nestlings. By focusing on females, the foraging costs of long tails would be more easily detectable because female ornamentation has fewer influences on a confounding factor, the mate's parental behavior. The authors chose to study Japanese barn swallows, whose tails are 10% shorter than the European barn swallows studied in previous experiments. So if the aerodynamic hypothesis is correct, the Japanese barn swallow tails should be close to the optimal tail length. Thus, experimentally shortened tails would be farther away from the optimal length, supposedly decreasing the female's feeding rate. In contrast, the sexual selection hypothesis predicts that shortened tails would increase the feeding rate by reducing long, costly tails. The author showed that when a swallow's tail was not shortened, feeding rate decreased with decreasing female tail length. However, when the tail feathers of females were shortened, feeding rate of females with originally shorter tails improved. These results do not support the aerodynamic hypothesis. If a long tail is advantageous for flight and thus foraging, shortening the tail of females with originally shorter tail feathers would reduce their feeding rate, which is opposite to the observed pattern. These results also appear inconsistent with the sexual selection hypothesis at first glance. However, this apparent inconsistency can be explained by considering the differential cost of ornamentation, as predicted by sexual selection theory. High-quality females who cope with long tails are able to successfully feed their nestlings. On the other hand, low-quality females who do not cope with long tails, and hence have shorter tails, experience more difficulty to attain a high feeding rate, which was improved by shortening their costly tails. In conclusion, swallowtails do not appear to improve flight performance, even in Japanese barn swallows who have originally shorter tails. At least for originally short-tailed female swallows, long tails are costly. To find out more about this study, please visit the Journal of Ethology and Japan Ethological Society's website. Thanks for listening.